Welcome to my YouTube channel Modi Mechanical Engineering Tutorials. In this video I would like to explaining about slow cooling of plain carbon steel. So basically the steel portion of the iron carbon diagram is of the greatest interest and the various changes take place during the very slow cooling. So basically from the Austenite range of the several steels is to be discussed over here. So let us start to draw the iron carbon diagram for the steel category. So basically for the making a steel, so you should know about the Eutectoid transformations. So in case of the Eutectoid transformations, one of the solids, so in the case of the iron carbon diagrams, that will be the gamma phase of Austenite. That will be transforming by the cooling into the alpha ferrite plus cementite. So by the Eutectoid transformations, gamma austenite that will be converting into the alpha ferrite plus cementite, or you can say Fe3C. And by the heating of the alpha ferrite plus cementite, so you will also get the gamma austenite. So by the heating. So as per the iron carbon diagram, such kind of transformation from one solid to another solid, it will be at your 0.8% of carbon and around 723 degree centigrade. So this mixture of alpha ferrite plus cementite at 0.8% of the carbons, so it will be making a proper mixture, and that will be known as a pearlite. So pearlite is only found at 0.8% of the carbon is being present, or you can say at your Eutectoid transformations. So now let's see the Eutectoid transformation diagram of iron carbon diagram. So as per the iron carbon diagram, this x-axis that will be the representation of weight percentage of carbon, and y-axis that will be the representation of temperature in degree centigrade. Now as from the Eutectoid transformation, so that will be occurs at 0.8% of carbon. So there will be the point, it will be the 0.8% of carbon, and the temperature it will be the 723 degrees centigrade. So suppose that will be the temperature, it will be 723 degrees centigrade. So just you can make a one horizontal line from this temperature line and one vertical line from the composition line. So by the making a horizontal line and vertical lines, so that will be the one intersecting point. So this point is known as a Eutectoid point. And as per the solubility of the iron for the carbon, so that will be 0.025. So just you can make a one point over here, which will be having a carbon percentage around 0.025% of carbon. So that will be having a 100% solubility with the irons. So just you can make a one line like this into the solubility range with respect to the temperatures. So now as from the iron carbon diagrams, so that will be the temperature range around 910 degrees centigrade. So you will join a line from this point to Eutectoid point, and from this side it will be around 1147. So that will be the eutectic temperature line. So just you can joining of these lines like this. So as from the Eutectoid transformations, our gamma austenite, so this is the Eutectoid points. So if you want to study about the Eutectoid transformations, so just you will make a one vertical lines that will be passing through the Eutectoid points. So at above these points it will be the 100% austenite. So just make a, so this 100% austenite that will be transforming into alpha ferrite plus cementite, at which 0.8 and 723. So that will be the compositions and intersecting with the temperature line. So it forms alpha ferrite plus cementite. So that will be known as a pearlite. So by the proper mixture of the alpha ferrite plus cementite, so that will be known as a pearlite. So pearlite is only found at a 0.8% of the carbon. So for the better understanding for the slow cooling of the plain carbon steels, so if you learn onto the 0.8% of the carbon with the transformation from austenite to the pearlite, so that will be known as the Eutectoid transformations. But if you take any point before the Eutectoid transformations, or you can say below the 0.8% of the carbon, so that will be known as a Hypo-Eutectoid steel. And if you learn about the more than 0.8% carbon to the maximum 2% of the carbon, because up to 2% carbons, so that will be the category of steel. So from 0.8% carbon to 2% of the carbon, so that will be known as a hyper-eutectoid steel. So now I will take different alloying points which will be categorized by the hypo-eutectoid steels. Then we will be discussing for the pearlitic transformation, or you can say eutectoid steel, and one more point in between the hyper-eutectoid steels. So let's start with the hypo-eutectoid steel. So you will make a one transformation line at 0.2% of the carbon. So just you can see by the making of vertical lines at 0.2% of the carbon, so that will be intersecting at the various transformation lines. So first of all, that will be intersecting over here, then after onto the eutectoid temperature line. So for 0.2% of carbons, so that percentage of the carbon that will be dissolved into the space of the FCC irons. So here it will be the formation of the FCC structures. So after making one vertical lines from the 0.2% of the carbon, so upon the slow cooling, so nothing going to be changed if it will be once touch these lines. So that will be the intersecting points, so it will be known as a X1 points. So these lines, it will be known as the upper critical temperature line. Upper critical temperature lines. So basically that will be into the region of hypo-eutectoid steels. So the label as a A3 temperature line. So the allotropy changes from the FCC to BCC at a region around 910 degrees centigrade, that will be at a pure irons, and decreasing into the temperature. So the temperature is dropped down with the increasing of the carbon percentage. So as shown into the diagram. So that lines, it will be the transformation line from the FCC to PCC by the decreasing of the temperature as well as the increasing of the carbon percentage. So at upper critical temperature line, here that will be the phase of the gamma austenite, so which is transforming into the alpha ferrite structure. But carbon that will be having a dissolves, and it will be the formation of the single solids. So that will be the range is 0.025% of the carbons at these temperature lines. So just you can see these regions. So it will be only formation of the alpha ferrite. So in between these two regions, so that will be the alpha ferrite plus gamma austenite. So for 0.2% of the carbon and transformation line which is intersecting at a eutectoid transformation line, so that point it will be known as a X2 point. So which is also the transformation line from alpha ferrite plus gamma austenite, now which will be transforming into the another form of the solids. So this temperature line, it will be known as a A1 temperature line, or you can say lower critical temperature line. So now from these regions, that will be the enrichment of the iron and the solubility with respect to carbon and the formation of the only single phase, that will be the alpha ferrite, and that will be at 0.8% of the carbon. So that will be the proper mixture of alpha ferrite plus cementite. So that will be known as a pearlite. So in between, that will be the alpha ferrite plus pearlite. Now I would like to make a microstructure at the different points. So that will be the one point is here, then second point at x1, third point at x2, and one more point at room temperature. So that will be the point number 3. So let's start with a microstructure at point 1. So at point number 1, so that will be having a FCC structure with the 100% of the gamma austenites. So which is indication as 100% of the solids, and which will be having a gamma phase. So this is the microstructure at point 1. Now I would like to make a microstructure at the intersecting, or you can say at point x1. So once it will be touched the upper critical temperature range, so this gamma phase, it will be now start to converting into the alpha ferrites. So that will be making a one kind of pro-eutectoid alpha at the conversions from the gamma austenites. So just you can see the microstructure at x1 points. So it will be the formation of the pro-eutectoid ferrite. So now gamma austenite, that will be transforming into the pro-eutectoid ferrite. Now I would like to make a microstructure at the intersecting with the lower critical temperature line, or you can say eutectoid temperature line. So let's see the microstructure. So at point x2, so this austenite, now it will be transforming, or you can say converting into the alpha ferrite. So here it will be the starting point of the pro-eutectoid ferrite, but by the progressions with the slow coolings, or you can say temperature drop downs, so in between some grains that will be having a pro-eutectoid ferrites. So such kind of microstructures, it will be around the boundaries of the gamma austenites. So just you can see. And at point 3, so or you can say the at room temperature. So for 0.2% of the carbons, so by the conversion from x2 points, so that will be the pro-eutectoid ferrite is already found, but at the room temperature, so that will be making some kind of alternate layers with some regions with the conversion into the pearlite, because that will be the pearlite is nothing but that will be the mixture of alpha ferrite plus pearlite. So some regions that will be the formation of the pearlite, but that will be the not 100% pearlite. So here that will be the alpha ferrite. So these all act as a alpha ferrite plus pearlite. So that will be the making alternate layers of alpha ferrite and pearl cementite. So that will be known as a pearlite. So that will be the microstructure at room temperature for the case of the hypo-eutectoid state. So in case of the hypo-eutectoid states, so it will be firstly transforming into the pro-eutectoid ferrite. Then it will be converting into the alpha ferrite plus pearlitic structure. Now I will make a microstructure for the eutectoid transformations. For understanding of the eutectoid transformation, I would like to make some points. So here it will be the point number 1, or you can say 1 dash, 2 dash, and around room temperature, that will be the 3 dash. So first of all, making a microstructure at point 1 dash. So just you can see just above the eutectoid temperature line, so it will be the 100% austenite, or you can say gamma phase is being present for the 0.8% of the carbon. So once it will be touched the 2 dash lines, so at these points, or you can say constant temperature process, and that process it will be known as a Eutectoid transformations. So at constant temperature, this gamma phase it will be transforming into two more solids. So one solid it will be converting into two more solids. So gamma that will be converting into alpha ferrite plus cementite. So that will be known as a pearlite. So now I would like to make a microstructure at room temperature. So just you can see the microstructure for point number 3 dash. So at 0.8% of the carbon and at room temperature, the gamma phase now it will be converting into alpha ferrite plus cementite. So it will be making a proper mixture of alpha ferrite and Fe3C, or you can say cementite. So just you can see at room temperature for 0.8% of the carbon, so that will be the alternate layer of alpha ferrite plus Fe3C, or you can say cementite. So that will be nothing but it will be known as a pearlite. So pearlite is only found at 0.8% of the carbon. Now I would like to make one more point, that will be after the 0.8% of the carbon. So just you can take a point around 1.2% of the carbon. So just make a one vertical lines from the 1.2% of the carbon. So that will be intersecting at this point. So that will be the x1 dash point, similarly x2 dash point, and one more point at around temperature, or you can say room temperature. So that will be the x3 points. So now that will be the transformation from gamma austenite to the different phase of the materials. So by the hyper-eutectoid steel, so you can say it will be more than 0.8% of the carbon. So that will be the enrichment of the carbon into the irons. So at this transformation line, once it will be touched the x1 line, so that gamma austenite it will be now transforming into the cementite. So here that will be the region of gamma austenite plus cementite, or you can say Fe3C, because that will be the enrichment of the carbon into the iron. So carbon percentage it will be up to the 1.2%. So that will be formation of the cementite. So once it will be touched the x2 line, so that will be converting into the cementite phase. So this austenite it will be try to converting into the cementite, and from these regions at room temperature, so for 0.8% of the carbon, so that will be already formation of the pearlitic structure. And after the enrichment of the carbon at the room temperature, so that will be nothing but pearlite it will be already formed. So now this pearlite it will be transforming into the cementite. So in the case of the hyper-eutectoid steels, so that will be pearlite plus Fe3C. So basically two structure is going to be formed. So in case of the hyper-eutectoid steel transformations, so that 100% gamma austenite which will be converting into pearlite plus cementite. So now I would like to make a microstructure at just above these lines, so around this. So that will be the similar we already discussing for these points, but just change with respect to the weight percentage of the carbon. But in general forms it will be the 100% gamma austenite. Then I would like to make a microstructure at these points. So just you can see it will be just above the x1 lines, it will be the 100% gamma austenite. But once it will be touch the transformation line, so that will be converting into the Fe3C or cementite. So basically Fe3C it will be fixed at the boundary regions. So that will be becoming more hardened because of the enrichment of the carbon. So that carbon it will be occupying the space around the boundary regions. So it will be making a stronger boundaries. So that will be nothing but the excess cementite is being present over here. So at x1 point, such kind of microstructure you will find. So cementite, it will be present around the boundary regions. So this gamma austenite, now it will be react at the lower temperature, so it will be converting into the cementite. Now I would like to draw the microstructure for x2 points. So at this point, or you can say at x2 dash points, so that will be the gamma, it will be converting into the cementite. So here that will be at x1, there will be the excess cementite, it will be present, and the further the cooling it will be possible, so that will be the enrichments. So these grain boundaries, it will be much stronger because of the enrichment of the carbon at the lower temperature. So during this transformation line, it will be the formation of the cementite. So basically that will be having a strong portion, you can say strong phase. So that will be known as a Fe3C, or you can say cementite. So by the slow cooling with the higher weight percentage of the carbon, around 1.2%, so that will be the expansion of the cementite network. So at initially that will be the cementite is being present, but at the lower temperature that will be the Fe3C having some networks. So now it will be totally converting into the Fe3C and Pearlite. So now I would like to make a microstructure at x3 points. So here at the room temperature for 1.2% of the carbon. So at room temperature, it will be the formation of the pearlitic structure plus cementite structure. So basically pearlitic structure, that will be the proper mixture of the alpha ferrite and cementite. So these regions, it will be the formation of pearlitic structure, and around the boundaries it will be the presence of the cementite. So basically just you can find the microstructure at room temperature for 1.2% of the carbon. So just you can see that will be the alternate layer of the alpha ferrite and cementite. So that will be known as a pearlite, and in between the two grains, so that will be the one boundary, and that will be the solid boundaries which is formed by the Fe3C, because all the enrichment by the carbons, and that will be occupying the space at these boundary regions of the gamma phases. So that is the microstructure at the x3 point, or you can see for the room temperature for the hyper eutectoid steel. So I hope you understand all that three process of the hypo eutectoid steel. That 0.8% of the carbon, it will be known as a eutectoid steel, and in between 0.8% carbon to 2% carbon, so that will be hyper eutectoid steel. So I hope you understand this. If you like this, then subscribe and share more the mechanical engineering tutorials. Thank you so much and keep watching.